In this video, I'm going to show you how you can segment muscle fibers with CellPose within QuPath. In the previous video, we've installed CellPose to be run in QuPath or Fiji if you want to. So you can check that everything is well installed. If you go to extension, you should have an installed extension, the BIOP CellPose extension. Also, we define in Edit and Preferences the path where CellPose was installed, and here it's the one, so virtual environment where we install CellPose to run with the GPU. So here we have an image with 4 different channels. In blue we have 2A type muscle fibers, 2B type in green, 1 in red, and laminin in white, which actually stains the basal membrane that surrounds muscle fibers. So if we just look at the laminin, we can actually identify all the muscle fibers and a few other structures as well. So we'll see if we want to get rid of how we can do. So first thing when you're working with fluorescence images is to actually adjust the visualization parameters. So let's go back to the 2A. Here I can use the reset, so I'm not on the right one, so you need to check to actually select the right channel. If I reset it, now I barely see the blue channel, so I can either use the auto or do it manually. You have a gamma correction. I would really recommend not to use it because it's harder to understand what you do when you use a gamma correction. It's much easier to understand, to interpret what you do when you change the maximum display. When you decrease it, you see more and more blue pixel, and that makes sense because what we do here, for example, if I stop there, all the pixels that show an intensity in the 2A channel, in the blue channel, superior to 3343.3 are bright blue, saturating blue. And so if I keep decreasing, I'm going to have more and more saturating pixel, which makes sense. On the other way around, if you increase the minimum display, if I go there, for example, all the pixels that have an intensity inferior to 263.3 are black in this image. So here, probably I can decrease a little bit more. And you can look at it just in grayscale. Oh, I'm back here. I don't know why. All right, sorry. So this is the real channel. And so as you can see, you have fluorescence in the background, which is not specific to fibers, but that shouldn't be a problem because fluorescence that is within the muscle fibers really have the shape of the muscle fibers, while these other guys are just spurious, probably at the junction between fibers. Yes. I'm going to have to remove the grayscale and see both of them. So you see it's on the laminin, but it should be fine to actually segment my fibers. Now I can look at the 2B, which look fine. The red's going to be faint because I made a reset. Let's do it like this. It looks fine. So visualization settings is really important because you need to be comfortable with your image to see it as, you know, it's also pretty personal. Several people won't have the same way to actually set up their displaying parameters, but it's fine. What is important is really to be comfortable with the image so that you can actually see it well. All right. So we're going to first segment the fibers, and for that we're only going to use the laminin channel. And to run Salpos, we need to use scripts. So you can do it if you go to Automate, Show Script Editor. And then I'm going to go back. So actually, here we're already there. But if you type in GitHub TPCode, which is my identifier on GitHub, here, there's one which is the training I give about QuPath, whole slide image analysis with QuPath. If you go to script, we have a script to detect muscle fibers, fluorescence images with Salpos. So I'm just gonna copy and paste the script. If I go back to QuPath, I can paste it, parameters which pre-trained model you use. So we could use Cyto or Cyto2. Cyto2 is pretty performant, so we're going to use Cyto2. Pixel size, so here it means that we use full resolution. Channels, when you use the channel numbers, alright, I'm going to reduce it manually, sorry. Numbers, so if I go back to my channels here, I have 4 channels, but you start at 0, so 2A is channel 0 for the script in QuPath. So 2B would be 1, 1, 2, and laminin is going to be 3. So this is the correct channel. Then there's a normalization function that is global, so which is really good because it's going to actually do the normalization at the slide level. And so if you have regions that are outside, you know, when you run Salpos, you actually divide your whole slide into tiles. And if you have a tile which is in the background, when you do a normalization at the tile level, then you're going to normalize a tile with nothing in it, and there's much chances that you're going to find something in this tile just because the intensity levels are going to be just shrinked, and that won't be good for Salpos. Anyway, this is the right way to do it. Then you have probability threshold for your cells. With Salpos, it's a bit misleading because it's not between 0 and 1, but it's between -8 and something like 16. So basically, if you have too many muscle fibers in our case, or cells, you should decrease it. If you don't have enough, you can increase it. The flow thresholds, it's a bit harder to interpret when you're not very familiar with Salpos, with the method behind Salpos. I would recommend to keep it as the default value, 0.4. It should work most of the time. Diameter, so here I know that I need to increase a little bit. This depends on the size of your objects, and here we have fibers that are pretty large. We're going to define them as 100. We could do set expansions, but here we have markers only inside the fiber, so we don't need this. And then measure shape and measure intensity. It extracts measurements related to shape and intensity for all the fibers. So we're going to do that. So then you can run it, and it won't work. Why? Because the way this script works, it segments objects, muscle fibers here, within an annotation that's been defined before. And here there's no annotation, so parent that will be parent object at the end of the segmented muscle fibers. So there's no annotation that's defined, so I first need to define an annotation. So here, to actually segment the tissue, we can use the thresholder. I'm going to create a new class, tissue, and now I can start the thresholder. So if you type in create thresholder, when you do Control L, here are you going to go to classify, pixel classification, and the idea is to look at a very low resolution. So you can define several. So you need to define which channel you're going to use. So average channel is probably a good idea. You can pre-filter with a Gaussian, makes sense, and everything is going to be above the threshold will be tissue. So nothing happens. I think it's because my C, yes, was unchecked, and then so obviously I need to increase the threshold. Let's try 500 for example. So here it's not very regular. If I use a Gaussian, I'm going to have much more regular tissue. So here it seems that some tissue are not within the thresholded tissue, so I can decrease my threshold, for example. Okay, this looks fine. So then you can define a name like tissue, and so you need to save before creating it. So the good thing is that you could save it and then process this classifier for several slides. That's the idea. That should work pretty well on actually many different slides with the same, which are acquired with the same parameters. Alright, so I have my annotation here. Now I can run. I go back to automate, show script editor. Now if I run my script, it's running, and so it's tiling the tissue area, and now it starts to process it. So as you can see, many times, 57. So I'm going to speed up video so you don't have to wait for the entire processing time. Alright, it's done. So it took 3.5 minutes. Without the GPU, this would probably be more like 15 minutes, probably 12 to 15 minutes. So if you can install a GPU processing for cell pose, if you have a good GPU, that can be really worth it. Now, doesn't mean that if you don't have a GPU, you cannot use cell pose. I mean, 15 minutes, it's not a large image, but it's pretty large already. So that's not that long, and you can still process quite large images. You can run the script during night or the weekend, and so you can process quite a lot of data, even though you just use the CPU. So let's close this. We can have a look at the results. So looks pretty good. Now, so we see that, for example, this is not a muscle fiber. If I double click on it, I have all the measurement associated with this object. If I want to remove it, I can do it directly here manually by right-clicking on it and doing a delete object. That's nice. And obviously, if you do it, you need to describe it in the methods, but that might take a lot of time if you need to do it for all the wrongly detected objects. Something you can do if you're just interested in the number of detected objects. Let me show you. If I go to the annotation measurements, I actually have a number of detected object, number of detection, 3,344. So if this is what is interesting for me, I can just change the annotation. So let's say, for example, we can see here that we have many cells in probably, so it's not that we don't have fluorescence, but maybe we would say that, okay, this should be removed from the analysis because, you know, it's not the same laminin level. I shouldn't detect them. So we could have run the same script but with a lower probability for the cells to be detected, or what I can do is just altering my annotation. So first I need to unlock. You can see that this annotation is locked, so I cannot change it. But if I do a right click, you can do unlock, and now I can change it. So if I use the brush, for example, if I hit Alt button for alter, now I can change the annotation like this, and let's say, alright, so that won't be perfect. Here is just for the sake of the example, I can remove all this part from the analysis, and let's say, so if I hit move, let's say that, okay, I want to remove this entire part, I can use the brush, Alt again, And here I'm very low resolution, so that's going to be much faster. And I can remove all of this. So obviously that could have been done before segmentation, and so it would have been faster because there would have been less regions. And now if I go back to the show annotation measurements, no, sorry, to the, I did the detection. I want to do the show annotation. I look at the number of detections. I have 3,238, while I had 3,344. So I have a little bit more than 100 annotations less, 100 detection less. So that's one way to do it. Let's say that now we're happy, even though, you know, it's probably more things that we should have removed before, but it's, so let's say we're happy with that. Now we want to do an object classification. We want to identify the fibers that are positive for 2A. So let me go back here, 2A, 2B, 1. The thing is that we can have also fibers that are positive for 1 and 2A at the same time. So one way would be to actually define classes for 1, 2A positive, 2B positive, 1, 2A positive, and negative fibers. That would be, so, 5 different classes, and do it on this image. Or what I can do is just classify the fibers for each fluorophore, so for 1, 2A, 2B, and then apply the classifiers. And if I have muscle fibers that are 1 and 2A, then I will know that I also have 1 and 2A. So that's what we're going to do. There's an easy way to do it. If you do Control L again, there's something which is called Create Duplicate Channel Training, or you can go to Classify Training Images. And when you do that, you have a window that pops up asking you which markers you want to use for that. So we won't use laminin because laminin is for all fibers, but we want to have 2A, 2B, and 1. I'm going to hit OK. And now if I go back to my project, I have my muscle fibers image, and I have one for 2A, one for 2B, and one for 1. So I'm going to go. Oh, shoot, I think I forgot something. That's, you know, always good to show one main mistake. I didn't save it. So I should have saved my project before doing the duplicate training image, because as I didn't do the save, everything I did, the annotation, the objects were not saved, and now my other image are just empty. So I'm going to save it now. Just to show you here, this image is empty. Everything is empty. So I'm going to go back here. I'm going to remove these 3 images. And now that I saved it, if I do it again, create duplicate channel training images for everything but the laminin, now if I go to the next one, I actually have a detection. So I'm going to start with 2A, so I'm going to look at 2A only. I can even do it in grayscale. And now I'm going to define positive cells for 2A and negative cells for 2A. If I go back to my annotation, I'm going to use a new class which is going to be 2A positive. It can be whatever you want. And so I'm going to have cells that are 2A positive and cells that are negative, and I'm going to use the ignore for that. Whereas this kind of annotation, the point annotation that are useful for that, because here you're going to be able to actually select positive just by clicking one fiber. So I'm going to add 2 new groups of points. First one, I'm going to close this. I'm going to say this is 2A positive. 2A positive is selected. This annotation is selected. I'm going to do set class, and then I'm going to select the other one, and I'm going to select ignore for the negative and set class. All right. Now I'm going to define several positive cells. It's good to have, representative cells. I'm going to say that this one, which is pretty bright, is positive, and you can actually define the size of your dot. So I'm going to do it that so I can see it well. This one, but something that are, with less fluorescence, like this one. It's good to go different parts of your image as well. So this, let's start by defining like 5 different positive cells, and then same thing. So I'm gonna hit, so when I hit there, I can hit the M button to actually move. I'm gonna go back to this one. I'm gonna say, okay, so this is negative, this is pink. This is good because here we have, some dots. So just to show some example where it's not totally black. Something we can also try is to define this one is actually negative, even though it's super bright. So we'll see if it's able to differentiate these ones from the other ones. Let me just show you something also if you make a mistake. So most of the time you can try Ctrl-Z. I'm going to try it. Yeah, this works. But sometimes, for one reason I can't explain, it doesn't work. So what you can do in that case, this is a new point. So I'm going to delete this, sorry. I'm going to select again my IGNO class. Let's say I made a mistake. What you can do is you can click on it again and then move it to an actual negative example. And now I'm going to start an object classifier. So it's going to be train object classifier. And so first you need to define a classifier. We're going to use the random trees. Then we're going to use the measurements. So we're going to select measurements. And so here, so we think, so there might be some morphological features that could be associated, but we're just going to use the fluoro4. So we're going to use everything that is 2A. And that's it. If you know that 2A is incompatible with another fluorophore, you could use this fluorophore. This actually is a negative way to show example, but in this, when we're going to do 2B, we know that 2B and 1 are not, they cannot overlap. So when I try to identify positive 2B, if I use the 2B intensity and the 1, then if we have negative examples with 1, even though if there's some fluorescence associated with 2B, classifier, it's going to be easier, so it's going to know that if you have high 1 fluorescence, it cannot be 2B. Alright, so here we're just going to use 2A, apply, and then I can do a live update, and it's going to show me which colors are associated. So here, as you can see, I have tons of examples of tissue, and we don't want to use tissue, so I can, in the classes that are selected, so I could remove the tissue because it's not useful anymore, or here I can just select the classes, and here I don't want to use the tissue, I just want to use 2A and ignore, apply. And so, as you see, so when you have just a few examples, your classifier might diverge, and here everything is 2A positive. So I can give example, something that might be a bit counterintuitive. When you see that, you have the feeling that if you add new negative objects, it's going to consider these negative fibers as negative. It's because it doesn't have enough example. It's not always the case. I guess if I add a new positive example, that might do the work as well. Let's say that this is, yeah. Now, so you can do that to see which ones are positive, which ones are negative. So as you can see here, just giving a new positive example helps the classifier to segregate which is positive from which is negative. So here it doesn't work. I'm going to try to add other example as negative. Let's say this one, and you see it's start to be able maybe to find. So I'm going to say that this is negative, all right, and that works, while this is positive and this is positive. Very important, you need to have a balanced set of examples. So here we have the same number, we have 8 points for each of them. Let's say this is negative, and you see now he was able to actually see that these are all negative. This is positive, so I can try to add this. That might be difficult. Yeah, that works. And so now I can just add, so I have 9 points, 9 positive example, 9 negative example. This is definitely a negative example, so I'm going to say, okay, this is not positive. Here, this is tricky, but I can try. Okay, so I'm going to say that, this is positive. Let's say this is negative. This works. Now we need to check that it's working everywhere in the image. So I use the M button to navigate, to move. And yeah, so here the fainted ones are not considered as positive. So I'm going to add this one, for example. So this one is positive as well. It's pretty good. So I have an unbalanced set of examples. So here we have other ones. Okay, so this is negative. I'm gonna add this one, so we have to be careful that that helps. This is positive. This is definitely positive. And yeah, looks pretty good now. The faint one are considered positive, and that seems correct. Doesn't seem that there are negative examples considered as positive. Now let's just go back to regions that were more problematic in here. And that's fine. And let's just, so here it seems that there's nothing. Is it because we have nothing? Yes, we have nothing. All right. So now I'm happy with that. I have, so maybe, just for good practice. So here it's about, you need to have a pretty balance. So it's pretty balanced, but I still have one more example. So I can give one last example of negative. So let's say this one. All right. Oh, and that one was positive, and it's actually now negative, so that was a good idea. All right, and now let's say, okay, I'm happy with my segmentation, so I can save my classifier here. I'm going to save it as 2A and save. And I'm going to go to the next marker. So now I'm just going to do it on my own. I'm going to do the next 2 markers, and I'll be back when all classifiers are saved. All right, I'm done. So I did marker per marker, an object classification. So I trained an object classifier for each marker, and so now I'm going to apply all these object classifiers. So if you go to classify, object classification, load object classifier. So I have a classifier for all of them. I'm going to select all the classifiers, and I can apply the classifiers sequentially. All right, and now if I look at my annotations, so if I look at this, I have different colors. So the red ones are just negative fibers. The blue ones, 2A positive. I have the green ones like this that are 2B positive. I have these green ones that are 2A and 2B positives. This is actually not feasible. So if I see that I have a combination of markers that shouldn't happen, so I can maybe go back to my classifiers. So I could go back to 2A and 2B and see. If we look at it, you can probably see. So here, problem is that clearly it's probably more that this region should be disregarded because this is definitely not good acquisition here. Fluorescence saturated, so for whatever reason, I mean, but this should be excluded from the analysis probably. Oops. So let's go back and see what we have. So do I have other colors? Probably not. Let's check for it. No, it seems that I don't have any other file. So here it's also 2A and 2B, so that again shouldn't happen like in here. I think yes. So if we look at what we have, it's probably again some saturation. You see the laminin is really high, and so maybe also it's probably here. It's not 2B. This is probably just 2A, and this is 2B and this is 2A, and yeah, both were positive for both of them. It's probably because it saturates. So here probably because the blue, as it's high, I don't know, maybe we have a little bit of it in the other. Yeah, here it's because of this bubble actually. So I should have better trained my classifier, because here clearly we have this is positive and shouldn't be positive. Now if we look at the other way around, also we have some halo of green fluorescence. But here clearly by giving more examples, because I probably didn't give enough example of this kind of situation. That's why it failed. I would say that, you know, overall it looks fine, but we have, so that's one way to go back to your classifier and say, okay, I should add this example, so then it's going to work on, you know, most of the fibers, and that's going to be better. And then you can actually export your images, your measurements, and here. So again, if you just want to have number of detections, so here you have total number of detection in your annotation, and you have the number of 1 positive, 2A positive, 2A, 2B. I have 26, so clearly there's something not that good happening. 2B positive only. I also have 2B and 1, which is not possible as well. So I would have to go back to my classifiers and improve that. One way to go back now is also to go to the detection measurements, and you can sort these measurements according to one particular class. So if I go to my sorry, it's here, you know, the name here, so I can sort them according to their name. So here I have the 1 positive, I have quite a lot of them, 2A positive, and I just scroll over it. I have 2A and 2B. Yes, this is 2A and 2B, and as you can see here, so with the new version you also have visualization of the cells, and you can see that most of the time the blue channel is high, is saturating. So probably these guys should have been discarded from the analysis. These two, but that's, you know, that's another way to go back to your results. So here probably, that doesn't make sense that this has been detected as 2B positive. So I should go back to my classifier and say, this fiber is only 2A, and that's an example that should be used to train the classifier not to make this kind of mistakes.